So Brent Jones oversees Esri's worldwide strategic planning, business development, and marketing activities for land records, cadastral surveying, and land administration. As recognized inventor, Jones specializes in modernizing existing land administration systems and designing new GIS-based cadastral management systems for small and large government globally. He is a member of the URISA Board of Directors. You might have to tell us what that is. And past president of Geospatial Information and Technology Association, and is a current member of the United Nations Committee of Experts on Geospatial Information Management, sitting on the expert group of land administration and management. Esri creates systems that drive all components in land and cadastral administrations, including addressing registration, taxation, valuation, planning, and development. Holy moly.
I need to shorten that. And I need to shorten that.
No, that was good.
Much simpler person.
Right, there you go. What is URISA board? What is that?
URISA, that's the, it's essentially the professional association for GISPs, geospatial information system practitioners. So for GIS practitioners. So awesome. It's kind of like NSPS for GISPs.
Got it. Okay.
Yeah.
Much simpler there.
Yeah.
Cool. Well, thank you. Thanks for being on today. I appreciate it.
No problem. Well, thanks for inviting me. Essentially, here's what happened. I'll give you a, well, get started here on the agenda here, get off that main slide. I'll tell you a little bit about me that's a little bit, probably more personal than the standard bio. I spent most of my childhood in Maine, in northern Maine, and joined the Coast Guard after high school, got out of the Coast Guard, didn't want to go to work. So I went to college, studied surveying engineering by chance, might as well been throwing darts in the dark. I looked up geodesy in a dictionary, literally, and said, well, I guess I'll do that. And I just kind of fell into this, and one thing after another, became a land surveyor working in Maine and then I worked in civil engineering for several years, and then got involved in building GIS systems for utilities, and that's when I came to Maine came to Esri. And I'll give you a little quick story, and then we're going to jump right in. I was recruited by a client who was the VP of operations of Boston Edison, who came to Esri and wanted me to run pipeline for Esri. And after 30 or so interviews, because you'd have 3 interviews at an organized place, and this is Esri, so it's a pretty large, probably about the flattest organization you'll ever see. My last interview was with Jack Dangerman, the owner and founder of Esri. And, he said, I didn't get a chance to read your resume. Would you give me a minute? And I'm like, well, you're the billionaire. I'm the dude looking for a job. And he said, asked a couple tough interview questions. Actually, they're really tough. And then he looked at my resume and said, so you went to school at University of Maine? And I said, yeah, that's right. He said, they have the best program there, don't they? I said, well, I like to think so. A guy behind me 1 year wrote ArcView 1. And then he said, so you're a land surveyor? I said, yeah, that's right. Now keep in mind, this is 15 years ago. He said, what do you think of land surveyors? I said, you mean with GIS? He said, yeah, of course. I said, man, they're a tough nut. And he could explain. So my interview to come to Esri with the owner and founder of the company was talking for 25 or 30 minutes or so about land surveyors. Land surveyors carry a common theme globally. It's not just the United States. And I'm going to talk a little bit about some perceptions you may have of GIS and some things that are merely perceptions. And my goal here is to discuss the opportunities and where GIS is used, what's your client base, how can you expand your client base, your deliverables to your clients. And I'll give you a few resources at the end, and then I'll scare the hell out of you. But hopefully we have a little bit of fun. I got the chat window open here. So if I glance off to the left, that's because I'm looking at the chat, and I'm fine to take your questions, or if you want to unmute and just speak up, you won't mess me up. I can do this for a long time, so the break won't hurt me at all.
There you go.
Okay, all right. And I don't know if you guys know Esri. It's a very unique company. It's the second largest privately held software company in the country. It's owned by its founders. We have a bottom line like you do in your companies. You know, we do have to make a profit. But we have different bottom lines. I've given away, the first year I was at the company, I probably gave away $500,000 worth of software. Because people need this technology, and if they can't afford it, they wouldn't buy it. If they wouldn't buy it, you didn't lose a sale. So we really are based in trying to educate, trying to get information out there. And it's a really complex organization. It's a pretty simple organizational chart on paper. There's essentially Jack, a group of directors, and then everybody else. But we have an operations group that kind of runs the company. We have about 1,500 people dedicated solely on software development. 30% of gross revenues, about $500 million, goes into R&D. That's twice what any other company even grosses in this. So when we hit the market with something, it's been tested and retested internally and competed internally. If any of you are with educational institutions, we have a wonderful education program for donating, and certainly software extremely low cost. We have software for developing economies, a large international group. We're about 5,000 people. We have, in addition to the software that you may be somewhat familiar with, ArcGIS, we have a whole online cloud-based platform, which I'm going to talk a little bit about, because if you're not using GIS at all, that's such a great way to get started. You know, we have all the elements of a software company. We have a technical support group, and we have a professional services group that's nearly 1,000 people now. And we use that, our professional services, when we are pioneering a new market, a new technology. And as you know, this technology has been changing rapidly for the past, my lifetime, at least since I was in school in the 80s. And we have a large business partner program. Some of your companies may be business partners or may be interested in business partnering with us. We can't address all the markets that we are involved in and all the places this technology solves problems for. So we do have a large business partner community. So I'm going to jump right in on uses of GIS, and then we'll move away from that. So if this part bores you, go get a beer. If you're on the East Coast, get a cup of coffee. If you're on the West Coast, but I kind of want to. Surveyors are a diverse group based on who their client base is. So I want to kind of touch upon a lot of things that maybe it's adjacent to your work and you can expand into it. Maybe it's what you're doing and you can provide additional services, or maybe it's something that you want to take on, or maybe something you're not interested in at all. But forestry is one of the, in natural resources, is one of the early technology, one of the early markets of GIS. It was actually, the term GIS was coined by a Canadian who built a system in Canada for actually managing natural resources. So if you want to do 3D seismic surveys and you want to look for oil, look for gold, all the way down to analyzing, we have potato suitability on here. That's not very sexy. We have users who use our technology for actually siting vineyards. What's the soil? What's the slope? What's the sun exposure? What's the annual precipitation? What's the rate of precipitation? What kind of grapes would be best on this particular slope? Should be Chardonnay or whatever. So a lot in analyzing and optimizing food production as well. And of course, the E in Esri is Environmental Systems Research Institute. It started out actually as a nonprofit and figured out they couldn't accomplish the mission being a nonprofit. That's why it became a for-profit. This is my area, land information management. Everything I'm going to talk about will probably lean on this a little bit, and hopefully it relates to some of what you guys do. We have technology for managing parcels, very specific parcel technology. I can see a lot of you guys are on the West Coast. The entire PLSS is in the Parcel Fabric, and I'll talk a little bit about the But it's not used just for mapping the parcels, but used for valuing land, understanding what is impacting the value of land, and a whole wide variety of other applications in land. For those of you who work in government, you're probably well familiar. Our local government footprint's quite strong from the assessor's office to public works, managing permits, community development, developing land use plans. We actually have an application called Urban, which is designed for urban planners. It's kind of a soup to nuts application just for the desktop, where you can look at different design scenarios. We have another one called City Engine, which is kind of like SimCity for engineers. You put in a bunch of parameters and you actually see how a city is built out. But if you look at the lower right and the center in the middle, you'll see a lot of these dashboard type dashboards. The coronavirus dashboard from Johns Hopkins, that was Esri Technology. And what happens with dashboards is you have a map that tells a part of the story. But when you start adding graphs and charts to that map, you kind of fill in the story, and you can really absorb and communicate a lot of information at a glance, as you could see with the coronavirus dashboard from Johns Hopkins. But that just doesn't work in the planning and health industries. That also works in the engineering side of things, whether it's construction management, managing employees, managing pavement. For those of you that, I should have had some polls set up. I should ask you some questions like I assume a lot of you guys are starting to use drones. If you're not using them now, you're at least considering it. There's a lot of tools out there in GIS, from going from planning your flight to collecting control to actually producing orthos and mapping on the back end, all in the same ecosystem. But what we're seeing also, and I'll talk a little bit about this also, is the real-time traffic monitoring, real-time GIS, which is kind of like the Internet of Things. It's the same thing. You're bringing in information, whether it's dam deformation information or traffic information or weather information, and you're pulling all that data together and mashing it together to solve problems and answer specific questions. Water, wastewater management. This is, I'm sure many of you have worked on some of these systems. The way we're collecting data in the field for infrastructure systems, and sewer and water is a good one to discuss, because a lot of times surveyors work in projects. You'll go do a project, you'll do a boundary survey, you'll do a bunch of data collection for the design project. Most infrastructures work in systems. There's a sewer system, there's a water system, and the data collected is put into that system. We have ways to collect that information that goes directly into the system with some QA, QC workflows type things, but not reducing field notes or reducing from a data collector into some type of CAD type system, then into GIS. We've kind of optimized that workflow, and I'm happy to speak about that at length if that's of interest to anyone, because it's the same workflow for electric and gas utilities as well. They manage their infrastructure in a GIS system, and being able to collect data and input it into the GIS in an efficient manner kind of gives you I guess it gives you an advantage. But there's all types of ways, whether you're looking at canopy management, whether you're looking at outage tracing, all those things require really, really good data. And I'm sure many of you work in these areas. So I don't want to speak below or above anyone, because I know we do quite a bit of people online here. So some are going to understand what I'm saying, some are not. So hopefully I'm hitting the mark, but don't hesitate to type into the chat window. For new construction for fiber, GIS is heavily used. It's used also in the planning. Like I'm one of the fortunate ones to have fiber to our house, and when they built that whole fiber system, they really wanted to optimize on areas where not just there were a lot of houses, but the demographics would support having, you know, a more costly, high-speed internet. So when we look at how we put these things together, it's not just the physical surveying of the infrastructure; it's the analytical components of where do we go, why do we do, what do we do. Do we have any experience with Caltrans right-of-way acquisition and management? I don't know that directly, but I certainly can check. I do know that some DOTs use GIS for right-of-way management. The acquisition piece would be very similar to how you would do it now. You would just do it as part of the entire system. When I talk about the Parcel Fabric, I'll try to touch on this question because when you use the Parcel Fabric, you can have limited boundary corners located and still construct a pretty good parcel map. Okay, I'll get into more detail on that. Hopefully that'll work on that question. Public safety. Cops use this stuff like crazy. They use it a lot of times. I don't even know if we have one on this, predictive events. Like if you run an analysis of where crimes occur, you can figure out, you can predict where they're probably going to occur, at least some kind of location, and you use that to focus your police officers in those areas. So there's some also some security applications that we're probably not allowed to talk about.
Yeah.
But if you ever see like a parade or anything like that, you know, they use GIS for knowing exactly how safe every person is on a parade corridor. They know which windows could potentially harbor a sniper, things like that. Typically, it's just another application of 3D analysis. Not a lot different than sun and solar analysis, but certainly a different application. We have a program for responding to disasters. If you are in a community and you have a disaster, we'll come help you. We're not seeking payment or anything like that. We started this, I think, at the Northbridge earthquake in the late 90s, and it just kind of caught on. In 9/11, obviously, we were a heavy participant, and then it came Hurricane Katrina and Rita, and we just kind of built out a whole infrastructure of support. And that ended up actually building applications and building all kinds of other things. I mentioned the coronavirus. We're probably up to here with the coronavirus, so maybe I won't talk about it too much. But it's a spatial thing. It moves spatially. And understanding strain tracking and how to respond and how to track. We made a whole series of applications of tracking and tracing for local government and national governments, and also for vaccine distribution. And those are all made freely available to anybody who needs them. Pretty much, like I said earlier, if you need the technology and you can't afford it, it solves, you know, critical humanitarian problems. You know, we've got ways to get around that whole cost issue. But on the other side of that, on the commercial side, we do charge. So, like if you want to cite a store, if any of you guys have seen Bar Rescue, the TV show that uses Esri technology. For those of you who haven't seen, essentially, there's a bar that's failing. They do a demographic trade market analysis of an area, and they come in and figure out what the menu should be, what the what drinks you should serve, how much you should charge, what the place should look like, and everybody. And it's all a great big success. It's all kinds of property management, all kinds of understanding real estate trends and patterns. And with changing weather patterns, the insurance companies are stepping up their game also to try to understand how to more properly and equitably charge for different types of insurance coverage. All right, now this is getting a little closer to the meat here, because BIM and GIS are they're more than a handshake. They're really becoming integrated. There are tools for managing the interior structure of a building, the GIS tools. There are engineering tools for collecting data in BIM models and how to exchange and share and use that information. I've got a couple slides that are from the old days when I did some civil engineering work at Esri early on, and I want to discuss those because those also apply here. There's a lot of apps for the field. I'm going to talk about these in detail about how they work and why they work. But if you want to just collect data in the field, the idea of needing heavy iron data collectors is probably past. You can use your RTK receivers with an app on the iPhone and collect that information directly into a cloud or an enterprise geodatabase. And that's how this data is being collected and used. I'll go into detail on that because I know that's the core of what a lot of you guys do. And maybe there'll be something that can help you out there. Hopefully some of you guys are doing some LiDAR remote sensing stuff. There's all kind of tools inside GIS for managing all this stuff. And again, a lot of this is designed for facilities that need to process and use this data as part of a system, as part of what they're doing, and not necessarily just a specific project. And we would be remiss if we didn't talk about cartography. GIS kind of came from maps, and then and it's not really maps anymore, believe it or not. Everything in a GIS is in a database, and the map that you see in GIS is drawn from that database. So you kind of instruct the database on how to draw the map, and there's all kinds of cartographic stuff, and it gets pretty easy too, because as you're doing your work, we have this smart mapping tool that kind of tries to guess what you're trying to do and suggest colors and different map styles and that sort of thing, which is, as Jack Dangerman would say, it brings cartography to the mere mortal. Okay, now we're going to jump in here. All right. This is from my early days in GIS and surveying. Like I said, I studied surveying engineering. GIS wasn't even a term. And through my university years, it kind of budged, kind of emerged as a term. And this conflict between surveyors and GIS began. And hopefully some of you guys have seen this cartoon. If you just search, the real surveyors versus the GIS monster, you'll come up with this cartoon. But GIS has a lot of meanings, okay? And I'm going to try to do my best to explain what GIS is. It's not an application. It's a comprehensive geospatial infrastructure. It's a lot of pieces working together in a cohesive services-based environment. Whether it's managing data, mapping and visualizing that data, which is what we're really accustomed to. It's content, it's national data sets. For example, many of you probably do flood certifications, where the national FEMA firm panels are available online as a web service. And for those of you not familiar with web services, like I said, I'll dig into that. It's understanding the spatial analytics. It's how we share and collaborate. It's really changing. It's changing how we operate our governments, and it's changing how we operate our companies and how the private sector and public sector actually work together. Has a lot of ready to use data. I mentioned the FEMA maps. It has much more. This Living Atlas is the largest global collection of geographic information. That information can be static, like the NAPE imagery or Maxar imagery. It can be dynamic, like weather or ship location or airplane location. It all has a common geography or a way to overlay. and data comes in many different projections, many different data types. And the core engine, the core abstract engine of GIS takes data and puts it from a wide variety of sources and services, and then abstracts that and serves it back out of services. Now, there are authoritative and official data sets, but there is also user contributed data sets. If you were to do a wetlands map that you thought was pretty important, that you thought everybody should have, you can publish that map and everybody can use it. You can also publish that map and have just your organization use it as well. Any questions on that, on the content? All right, I'm gonna keep going. So keep in mind, I can see the chat. So as you heard from that embarrassingly long bio, my area is land administration. Land administration it's who owns the land, how we use the land, how we tax the land, and how we plan and develop the land. So it's a pretty broad definition, but we do a lot of valuation tools. If you read the New York Times, the Chicago Tribune, or Bloomberg, they've all, and the Washington Post, all within the last couple of months have published information on the inequities of property valuation. We have a bit of a task force working on that to show how location really makes a difference in valuation, and using the valuation tools. There's a geographic weighted regression, there's force-based classification, which is a machine learning algorithm for actually figuring out how these things work. Building small cadastral systems like a parcel map for a municipality or county, or large ones like the Land Title Survey of British Columbia is entirely in this Parcel Fabric technology. One of the key elements that makes our land system in the United States work as well as any other land system in the world is how public our information is. One of the things that makes this openness, this open and transparency, is really part of the secret sauce. When it comes to valuing property, you know your value compared to your neighbors because that's public information. If that information was private, you might contest your valuation more. You might, or the assessor, the appraiser might play games with the data. In some places that happens anyway. But the fact that all this is open, you can see who owns what and you can see how it's valued, is a key tenet in kind of the American land records system. We have tools for entering deed descriptions. Probably not as sophisticated as you guys use sometimes, but I'm certainly straight Kobo stuff. And the reason we developed that was we found one tax office that was entering in the deed description 6 times. They'd check for closure, then they'd go to something, close, then they'd go to somebody else. So we just developed this little tool it's free, you can download it and use it. For mapping, just Koboing in a deed description. Oh, and by the way, when I first came to Esri, this really kind of caught me off guard. One challenge about GIS is the nomenclature. It's like you have to have the secret decoder ring to speak the language, and it's a real problem. And so I get there, and I asked, they said, well, Kogo's coming in ArcView. I'm like, really? Well, Kogo to a GIS person is different than Kogo to a surveyor. So I have a question here. Where can we find the free Kogo tool? If you search, just search Esri Parcel Drafter. See if that comes up. If that doesn't come up, I'll get to it. I'll get to it, but it should pop right up. It's a free download and it's what it's for doing a parcel. And one thing different also about surveyors and GIS practitioners, surveyors are generally interested in that single parcel or group of parcels in a subdivision. The GIS professional has to get all those parcels, every surveyor's, all of them, into a seamless fabric. And I'll explain how that works. It's a mathematical problem. because we know no two surveys agree. If that's the case, then if we agree on that and the world is round, then we can come up with a solution, which we've done. But cadastre also extends well beyond just what we know as land, but it goes underground and marine. There's fiscal cadastres, which is kind of what our parcel maps are, is just for taxation. You know, there's tenure cadastres, which actually, you know, the parcel map is the legal ownership. So it's a pretty broad field. Now, how did we get to where we are? Computing systems have changed radically. Mainframes and minis, I worked on those, even though I'm not that old. Workstations, desktops, web servers. We're highly in a client server environment right now. That's probably where you guys do a lot of your work. And we're rapidly moving into a cloud device system. And I'll explain how that works. This client server environment is moving to web services and apps. And I'll explain that, web services, so don't get hung up on it. But if it's the only thing you take away from my talk, I'll be successful. We're not working in isolation, we're working connected. We don't have to model out everything we do. We can share data with maps and layers very differently. We're moving from static to real time, distributed computing. We're not building as much technology anymore. We're configuring existing technology. Technology is moving so fast. If you customize too much, then when a new release comes out, you're stuck trying to get up to date and update your technology and update your training as well. And if you have a hard time attracting employees, you want to be on the most current stuff because that's what new employees want. You know, data is becoming way more open, 2D to 3D. I mentioned smart mapping and the type of analytics that we can do now are pretty amazing. Okay, this is the most important concept for if you don't understand web services that you need to take away from this discussion. Okay, think of a web service as a dial tone to your data. Someone can connect to it. They can, based on the administrator or the owner of the data, you can control who can see it, just view it, who can query against it, and who can edit it. It has feature level tracking. Now, it's all controlled with identity, just like your Gmail account or any other login thing. So based on your identity, you control who has privileges. Now, in GIS, you have a thing called a feature. Some of you I know, most of you probably know this, but I want to step through this because it builds my case for understanding the services. So you have a feature in GIS. A feature is a thing, like a utility pole, parcel, a road, a fire hydrant. A feature class is all of those things. It's all the fire hydrants, it's all the parcels, it's all the roads, it's all the utility poles. A feature service is that feature class published as a web service, as a dial tone. And depending on how it's published is what you can do with it. You can edit it if it's published as an editable feature class. Maybe you can only view it. Maybe you can just see the data and overlay it, but maybe you can click on it and see who owns that parcel, like a typical parcel map. What a web app is taking several of these services and mashing them together in an application. Okay. So think of these services as a dial tone to your data. You can use many of these offline. You don't necessarily have to have a live connection, but that's how data is shared. You do this every day. You pull up Google, right? Google Maps. That map is a map service. You don't like it? You click on satellite. That's an image service. You want to go from point A to point B? Well, you know, for some of you, I hope I'm not bursting your bubble. That's not happening on your phone. Those two coordinates are getting shipped up to a route service. It's doing the calculation and sending the directions back to your phone. So a service can do calculations as well as just be data, okay? Can be weather. You know, you can create a routing app to route you around a thunderstorm if you want, and put that on a simple app. So this concept of services is really important. And I'll pause here for a second. You might even be able to put in anonymously, or if you are embarrassed, just put just to me directly if you don't want your name to be seen. I want to make sure everybody gets that, because everything from here on out relies on how these services work. This is the modern architecture.
Yeah, and this is a lot of kind of what I wanted to cover too, because early on we had Orange County, California on, and they utilize this web-based services to deliver all of their stuff to all their internal clients. And it's seemed to be a fantastic program, and we didn't really dig too deep into it. We had some small conversations about it, but I'd love to see how we can utilize that as the database that you would basically just send the client an email with all of the stuff already loaded, ready to go in this project.
Already loaded. And the you can use this right now. The National Geodetic Control Network is a web service, and you can click on it and use that on your phone in the field.
Right.
You can configure these things to cache the data on your phone so you can work offline. You know, I know it's a long time ago when I did this, but I remember doing layout, and we'd take pages of layout because we didn't know which control we'd be able to find, what would be wiped out, if there's going to be a tree, if we had, and this just gives you access to all your data in the field as well. I'm going to give you a couple resources at the end of where you'll be able to take your control, all your projects in Excel, and make maps and make apps out of them, okay? And I have to tell you, we don't code when we make apps. We use app builders. Computer programmers are designed to make app builders, not apps anymore, okay? And I'm not really good at this, but if we have time, I mean, I can even show you how to do it. But I can point you to a lot of resources too.
That'd be perfect.
Yeah, okay, just started using web servers to inform our field crews direct to their data collectors. Absolutely, that's great. I'd love to talk more about that. So now these web services, okay, so we take in data imagery. Maybe we take it in as a service. Tabular information like out of a CAMA system, vector data, kind of self-explanatory. All other types of data, LiDAR, CAD, BIM, these sensors, these real-time Internet of Things. We ingest all that information. Maps are maps of what you think. Scenes are a 3D web view. So if you want to spin around, look at something, okay, that's a scene. Just so you know, just working on the terminology here, because like I said, you don't want to have the super decoder ring. And then map layers are just those feature layers, those feature classes published in layers. Now we take all that data in, and now we publish it out as services. So if you want to be a GIS professional, you're going to use GIS Pro or GIS Pro. Maybe you're not. Maybe you're going to use AutoCAD. There's a connector to take this data in GIS to go into your AutoCAD. I got a link on that. You're all going to screenshot my last couple slides because I got a lot of resources there. I can paste them in too if we have time. But these field apps. So I'll go into detail on those, but there's ways to move data from the field to the office and the office to the field very simply, and be as high accurate as you want. There's no limit. There's no limitation to the limitation to accuracy is a limitation of your devices. Analytical apps for doing analysis of understanding. Viewer apps when you just want to communicate. Maybe you want to communicate to your client, hey, this is where we're going to be this week. This is what we're doing. This is where my field workers are. And you can actually have your field workers be tracked if they want to be tracked. Sometimes that's, some people don't like that. They think it's like the Slacker tracker. Other times it's a safety thing when you send people into hazardous or unknown environments. Geodesign is a term used to design the built infrastructure, taking into account all the natural landscape. And landscape's also kind of a GIS term, but all the natural features of the earth. How do you design with all those and understand the true impact instead of a typical civil design where you design it and then do a bunch of calculations? Design, look at the impact. How can, geodesign allows you to understand the impact of your design as you're working through the process. Story maps. I don't think I'm going to talk a lot about these. They're pretty cool. They were designed by the chief cartographer of National Geographic. I know many of you have read National Geographic, or at least looked at the pictures and the maps and read a little bit. Well, that's what story maps do. People look at the pictures, they look at the maps, they don't read much. That's what a story map is. So if you want to do a story map of a project, maybe, hey, this is what the initial recon looks like. This is what the control looks like. This is what data collection looks like. This is how our analysis to determine what we're doing here. These are the documents we had to review. This is the research we had to do. And here's the conflicts that we uncovered, and here's applying the evidence that we located, and here's applying the rules of evidence. You could have a story map of the whole process of a boundary survey, for example. And then there's dashboards. Okay, again, a dashboard is like the coronavirus dashboard. It's a map with indicators of what's going on that map. Okay, I have a question here. By the way, Sean, your last name, that sounds like Sear. That's a big name from where I'm from in Maine. If you're a Mainer, here's a shout out. If not, well, there's a lot of Sears in Maine. Now you know that. How do you convert large non-GIS databases to Geoides? Okay, example, cataloging maps, acquisitions, easements, all of which are constantly changing due to development. Well, depends on what you're doing. Are you maintaining a system like a DOT for maintaining those easements? Obviously that, if they're coming from a CAD file, there's an import set of tools from a CAD. The challenge we have with understanding easement change is not necessarily the mechanics of doing the work to get that information into GIS. It's knowing where the information is. We don't have a good connection of our registry systems, our recorder's offices, to the assessor's office. So the assessor's office, which generally maintains the parcel map, except for those of you guys in Utah, that's done at the recorder's office, which is pretty cool. There's not good communication from the recorder's office to the assessor's office. So there can be a change in the recorder's office in an easement, and that doesn't show up. So they can, a lot of times the assessor map is just, the current deed with limited information, as opposed to the whole chain of title, which is getting to be more of a trend to have those two offices integrated. Okay, this is an unauthorized diagram, but it describes, and it's kind of messy, but it describes what's going on. Data is input, and Sean, sometimes it's manual, sometimes it's automatic, and sometimes it's just connected into GIS, and it's published out as services and consumed by all these apps. This is kind of what that infrastructure looks like. Okay, I'm gonna take a drink of water here. All right, what are your opportunities out there? How do you take the limited information I threw out there and expand your business or get into new business? Okay, I want to talk about parcels. Nobody knows parcels better than surveyors, and there's only one state, I believe, that requires licensed surveyors to do the parcel mapping. And on a side note, they don't even do a very good job of that. Is anybody from New Jersey here? The New Jersey requires land surveyors to do parcel maps for the assessor's office, but they're no different. They're no better than done by anywhere else. Yeah, that's true. Managing the system is usually a time budget challenge. That comes down to a communication issue of how do you really communicate the value of a system. And the more people that use the system, the more valuable it becomes. Yeah, that's right. got requests for surveys because the appraiser's boundary shows the client's house and the neighbor. Yeah. Parcel maps are not very good generally, but this tool, this Parcel Fabric, now bear with me here as I go through this, okay? Because this is a service that you can provide to a local, to a county or a municipality who maps parcels and do this the right way. Inside ArcGIS Pro, there are defined workflows. It's all standards based. This gives you a single source of the truth. You can share data, you can multi-user, and you can improve the accuracy, and it integrates with registry and CAMA, okay? So how does this thing work? So you have a Parcel Fabric, okay? Parcel Fabric is made up of, it's a survey network of record measurements. Bear with me, because this took me, when we built this 12 or 13 years ago, the first version of this, it took, I was new at Esri, and it took me a while to grasp this. So take the plans and deeds, take the record measurements from the plans and deeds and build your parcels out, okay? They're not going to fit. There's going to be conflicts, right? Surveys don't match up side to side, but put in all your record measurements, okay? Now, much like any measurement network, for those of you that work in photogrammetry, in the middle of a block, you can have some funny things happen. If you're doing a long linear survey of a photogrammetric survey, you can have real inaccuracies that happen in the middle. So what we do is we pin that down with control points. So let's do the same thing with this Parcel Fabric. We built this measurement network. It's a bit afloat, okay? But we can do some math against it because it is a measurement network and we know the measurements. We can actually perform least squares adjustment. What's that do for us? Well, in mature systems, it improves the accuracy of your system. In immature systems, the immature measurement, the immature systems, it shows you where your fabric is inaccurate or weak. Okay, so you run a least squares analysis to look at it and say, I need to do some work over here. Okay, record or measured in the field, record measurement. Okay, now I'm really careful about how I say this because sometimes the record measurement and the field measurement are the same thing. Okay, but what we're doing is we're building this from plans and deeds. We're not building this from field work. So, but we do know the quality of measurements. We know the quality of the record. Some of them are good. Some of them are whiskey surveys. Some of them are, wagon wheels. Some of them are crap. We weight them appropriately so we get kind of a good idea what's going on. Now, we know it's not perfect, but we can pin that fabric to the ground with control. Now, in a normal adjustment, control would adjust with the measurement network. In this, the control is fixed. The control is a survey point. This might be a corner of a recent survey that you don't want to participate in any adjustment. You want that to be fixed. So you use the control points as you have them. And by the way, the PLSS now is all in the Parcel Fabric. Okay, so those can be used if they're accurate enough. If not, then they can be improved as well. Now, you take this fabric, okay, and as we adjust, you can adjust in small pieces or big pieces. We're doing the exact opposite of what drives you guys crazy. What drives you guys crazy is you bring a survey into the GIS dude or gal, and they warp it to fit their system. Drives you nuts, right? I mean, you spent hours getting that thing down to 100th of a foot and getting all those Autocad things to balance out and be perfect. And then they just go ahead and warp it. This does the exact opposite. This holds your good surveys fixed and warps all the crap around it, okay? But it does it mathematically. You can undo it and redo it. Done properly, this can be connected to the PLSS if that's done properly. And when the PLSS adjusts, this whole fabric can adjust as well. So It's a dynamic mechanism for maintaining and improving accuracy over time. As data gets better, the Parcel Fabric gets better. Any questions on that? Usually surveyors like, there's a little pushback here because it's generally not surveyors doing this work. But I will tell you, when I go into a county, and this was built by a surveyor, I can tell. When it's built by a GIS guy, I can tell as well. So it's like a skill factor, kind of, yeah, but what it's all based on, it's all fitted to the control points. If you want to put a lot of control in, you can do that. If you want a little bit of control, you can do that. I think it's a full employment act for surveyors. How to sell it, that's a different story. You know, as you know, for those of you that work for government, you know, government moves a fair amount slower than technology.
Danny had his hand raised up. He's got a question for you.
Yeah, go ahead, Danny.
So if I got this right, you're saying that that method that you just explained will adjust based on the data that you get from the surveyor, as opposed to warping the survey data to make the fabric fit within the data? Does that make
Exactly?
Okay.
So if I'm the GIS guy and you showed up with a new subdivision, and I know you use some RTK, maybe use some GPS on there to get some good fixed points. And I know, maybe you got 2 or 3 really good control points, and then you did, even if it's 5,000, 10,000, I mean, you did good work.
Mm-hmm.
I would weight that as, I'd call it all control.
Okay.
I adjust it.
Fair enough. Very cool. Thank you.
Yep. So there's several other tools. Hopefully the person who was asking about the parcel drafter found it. If not, we can revisit that. We talked about the Parcel Fabric. There's also a tool for creating map books. As much as we're all digital and everything's cool, they're not going away. All right, so you can just crank out map books. And then for those states, and for those of you that work for states, we have tools for aggregating those parcels to a regional, from the county and municipalities to regions, and then to the state, all based on services. This also works in 3D. You might not think that's a big deal. It's a huge deal. And it's always in the West, you've got a lot of subsurface minerals. In the East, you've got a lot of skyscrapers. And what's happening in New York? Why is New York concerned about this? Well, taxes. Raising taxes is generally political suicide, right? So what do? Well, you make sure everything is taxable as taxed. You map everything, right? You analyze the hell out of it and tax it its highest and best value. Highest and best use. And then you tax what's taxable that's currently untaxed. I can sell you air rights so you can maintain a view, or you can build over my building. That's a parcel. That's a 3D parcel in the air. It has value and it can be taxed. And we're building a system for New York City to map and do exactly that. Kind of cool. Same thing happens on the inside of the building, but I'll talk a little bit more about BIM in a minute. I threw this slide in there just because I want to show you some good examples of some different kinds of dashboards. One for analyzing value, and some crime reporting. There's all kinds of different ways. And again, these are configured. If you have data as a service, you can configure these dashboards yourself. This is not a programming activity. All right. Some of the high-end analysis in GIS takes a fair amount of work. Again, must have my slide automations on here. But configuring these apps is not difficult at all. Okay, so 3D GIS. What is this digital twin 3D city? What's this all about? Okay, this is literally taking the built environment, modeling it, and then doing stuff, right? This particular one is looking at flood. So you can actually look at how this area is going to be impacted by a different type of flood. You know, I'll just let this scroll a little bit. You can see who's impacted at what level. Yeah, it sounds really valuable for beachfront. It is, and actually, there's a lot of work going on with sea level changing. Some places it's sinking, some places rising. Of what that actually does for property values. It's quite high impact. So there's ways to capture this reality, this kind of imagery. This is a new application. I'm not fully up to speed on it, but it is a method. It's a rather modern method for capturing imagery. Your typical IMU data, and then pumping that directly into GIS for developing orthos and texture meshes. What's happening with this kind of what would be normally an exterior workflow is all becoming part of kind of the GIS infrastructure. All right, we're going old school here. This slide is probably 10 years old, but it does a good job of conveying what some of the things I'm trying to say. When we build infrastructure, and keep in mind, there's a proposed $2 trillion infrastructure plan, okay? Everybody wants to get a piece of that. First thing we do is we plan. We use GIS for that. Once we know what we're going to build, then we call the surveyor and we collect data. We get a bunch of data, we do some analysis, we design, we build it, and then we call the surveyor again to as-built, and then we operate. 75% of the cost of infrastructure is in operations and maintenance. 25% is in design and construction. 75% of the cost of infrastructure is O&M over its life cycle. 25% is design and construction. When we save money in the first phases of planning and data collection, we lower operation costs. So we have the GIS tier at the bottom, we have the surveying tier in the middle, and we have the engineering tier at the top. I would encourage, I know many of you surveyors work up into that engineering tier. I would encourage you to work down into the GIS tier as well, kind of expand your footprint. This is a sloppy diagram I put together to try to describe what I just said, is that good data management practices throughout the project save on operational costs. That is your pitch to do things, to collect data the way you want to, but you manage it in an enterprise geodatabase. You manage it centrally. So those folks doing the analysis and design are using all the data that you've gathered, not just some of it you've passed along. So you think of this as this data as whole. You think of it holistically. Okay, and here's just a nice little animation of what you can do once you have your BIM data in GIS. You know, and how many more things you can do if you collect your data properly. I mentioned this one, the New York City piece. I mentioned the taxation part. The other part of the BIM integration is the tax mapping of condominiums. 93% of the condominium conversions in New York City are done in Revit. And so they need to take these Revit files and get them into GIS. You can do that. It's nearly a drag and drop. The reason they need to have those 3D Revit files of the units in GIS is because they need to do the view shed analysis. They can't go into every unit. So what happens is there'll be, someone says, well, I can't, I'm looking into the building next to me that, you can't value my property because I have a view. When really the dude can see the Statue of Liberty. We can put a cursor on the window of that condominium unit and show the view. So we can value that. We can make sure that person is contributing to the tax base properly. So the other elements besides the taxation piece is the amount of time saved by just taking Revit files into their 3D tax map into GIS. It's pretty easy to do. Something if you guys have ArcGIS Pro, that's something fun to play around. I'm from old school. I did a lot of AutoCAD in my early days, and whoever thought you would see Esri at Autodesk University and Autodesk at RUC? Kind of fun. So we're playing together. This is what the integration of BIM and GIS kind of looks like. How you think about where you fit, where your services are, where can you expand into the GIS side? Are you doing enough on the BIM side? Is this going to be an issue with the new infrastructures packages coming out with specifications? I don't know, but I do know that the large facility builders are all using BIM. And I assume a lot of you guys are doing BIM as well. This is just a slide to show you how the actual elements, how they go together to power the different apps of managing, understanding performance, what are the issues, typical change order type things, document review workflows, the whole coordination, project coordination stuff. Real time, I mentioned this. I just want to put this in there so you'd have access to a slide that showed you a few different types of sensors if you get involved in anything like that. This is going to become bigger and bigger, particularly with using GIS to track cargo. Think of the Ever Given ship stuck in the canal there. What if your stuff was on that ship? You kind of want to know where it was and what the condition was of that. Again, I'm not going to go into detail on this. For those of you that are interested in artificial intelligence, deep learning, spatial sciences, there are limitless tools for understanding and uncovering trends and patterns in your data. Now, this is going to be a little bit more applicable to you guys. Field Maps is a full system for managing field operations and collecting data. You can plan where people go. You can tell where they are. You can have it set up for collecting data. Now, I told you I'd explain this, so I'll explain it now. When you collect data in GIS, you don't collect it in a file and then upload the file. We have these services, right? We have these feature services. So if I want to go collect a feature like a tree, I would have a feature service already published as a tree, and I would have that be editable by my field crew. They'd walk up to the tree, put the GPS on it, hit collect, and it would collect that tree, just like that. If you're disconnected, that would go cache onto your system. If you were connected and you wanted that to go back to the office or online in real time, you can do that. My vision coming to Esri was to be able to sit in the office with 3 52-inch plasma screens, watching my 3 crews and understanding what's going on. Crew 3's wrapping up. Hold on a second. Let me do some comps. Okay, can you do one more search over here? Send some coordinates, do some search. They're good. Okay, on your way home, I'll have some layout for you to go set some pins on your way back. So you can use this concept of services office field communication in a whole new way with survey. This quick capture application, This is what we call the fat finger application. You know, if you're collecting the same thing over and over, like a sign, like a stop sign, just configure a button for a stop sign, bam, hit it once and you collect it. Okay. Not really for our line of work. We would use more like the Arcgis Collector App, which you would configure how you want data to be collected in services, connect that collector app to those services, and it just works. And again, if you're using an iPhone or an Android, you pair actually GPS the same way you pair a Bluetooth speaker. We collect all that height information, all that geotechnical stuff from the GPS that goes in as an attribute of that feature. So you can collect that, and you can try all this stuff out too. There's trials for all this stuff if you want to give it a shot. Okay, so I told you I was going to scare you a little bit, so that's where this comes in. I was listening to Squawk in the Morning the other day, and Nightscope, which is like a robot security company, had this quote: "The world's going to change more in the next 10 years than the past 100 combined." You know, I believe that. You know, you've probably seen the quotes. You know, a Sunday Times has more information in it than, you know, 17th century man came across in his lifetime. So we don't know, but we know it's going to change. It's going to change a lot. We can see from things that happen like Facebook. There's no journalists, there's no content providers, no photographers. It's the largest media company. Airbnb has no rooms, no receptionists, no free breakfast, and it's the largest hospitality company. These things can get way upended. Uber, and I'm going to use Uber as an example because it describes what I'm trying to convey regarding change. No cars, no manufacturing, no repair facilities. How did Uber do this? Okay, Uber was massively disruptive. The disturbance or problems that interrupt an event, activity, or process. How were they disruptive? Okay, the enabling technologies for Uber, they didn't use one thing. They combined a whole bunch of stuff, all right? They combined the cloud, right? Cloud didn't exist 20 years ago. They used people's ability to download an app. Before 2007, nobody could download an app, let alone use it, all right? Of course, some of you guys are going to recognize this as a GPS satellite. Street network. I want to comment on the GPS and the street network. These are both public services, by the way, for those of you that work for government. This is why open data and services is so valuable. GPS, 99.99, it's probably 5 nines now, of users of GPS weren't considered when they designed the constellation. That's for putting missiles down smokestacks. Look at what value it has provided to society. The street map, this was done for census. And then a couple companies took it, ETAC, GDT, you might know them now as TeleAtlas and here, and they've taken this, and TomTom, they've taken this information and turned it into commercial products, and now Google, and so now the street level network, now standards. It's very important to operate and use standards because you can connect these services and technology so many different ways. Look at payment. Remember the first time you put your credit card in online? Yeah, you deleted it off. You said, I'm not doing that. Now it's like, it's a no-brainer. So Uber combined a lot of these things to create it. But what's happening with us? Okay, let's talk about this disruption. Okay, we've seen these. Here we use Google Street View. It's pretty cool, huh? What about Cyclomedia? You guys may have heard of these guys. This is like Google Street View on steroids. Single centimeter LiDAR on this thing. All right, and they drive the speed limit, and they're collecting that level of accuracy, not just of anything they can see building wise. Super high res stuff. Okay, here I mentioned those guys. Street mapping company. They've got these sensors. Why did 6 German car companies buy this company or buy controlling interest in it? Any idea? It's brilliant. Because with autonomous driving, we need better information. We need more current information. Mercedes, Audi, and BMW have the ability to turn every one of their cars into a real-time sensor. How's that for disruption? Okay. Okay, that's the scary part. Go to willrobotstakemyjob.com. Surveying and mapping technicians, 96% chance you're going to lose your job to automation. You're doomed. Okay. It doesn't mean the professional level stuff, the big stuff's always going to be there, and that's going to continue to change. But the low level tasks, they're going to be automated and be easy. Don't take my word for it. You can go to that. And it's fun to play with a whole bunch of different job descriptions. Transformation is a thorough or dynamic change in form or appearance. Transformation is disruption that you do to yourself, okay? Uber didn't cause their disruption. One of the major contributing factors to Uber's success was the apathy of taxi drivers. When you went to a different town, you had to find a different taxi company. That's kind of a pain, right? Taxis were late, not on time. All of a sudden, somebody figured out how to solve that problem, make it cheaper and make money at it. It's happening in a lot of things. How do we do that for us? How do we transform ourselves before an external force disrupts us? I talk to recorders as well. Why do I have to go to 3,641 recording jurisdictions? Why can't I just go to one? I can't even go to one for a state. A couple states can, but most states you have to still go to the county or the municipality. That's not, somebody's going to disrupt that. So GIS itself is very disruptive and transformational. Everything we do in GIS, we don't invent. We take all these other things out there, artificial intelligence, machine learning, the ability to use apps, the BIM design and modeling technology, high accuracy GPS. We take all that stuff and use that to continue to disrupt ourselves and build disruptive technology. So as we evolve, you know, the surveyors, you know, this is kind of where we are now, right? Kind of start out in the field now on the what's next? I don't know. But I do know that if you don't stay current, you'll be limited. A couple screenshot this, and I'll share these resources out with you. We have these meetups every now and then. If you're in the valuation side of things, let's see, Assessor and GIS meetup. If you're in the Parcel Fabric, if you're interested in the Parcel Fabric, we go into a great deep dive, and if you just search Meetup Parcel Fabric, it'll pop up. All the past ones are recorded, and they're on the Esri community. So you can go to this spot, communityesri.com, search land records. Again, this will be all in the slides, but all that information is available to you. Screenshot this one, please. When putting this together, I said, what 3 or 4 things do I really want you to do? First, I want you to understand services. If you understand services, you can do all 4 things on this slide. You can take Excel, download maps for Office. You can take Excel. You can make a map of all your control. You can make a map of all your projects. You can use Excel with Arcgis Online together. Very easy to use. If you're first timer to GIS, never been here, it's a good way to start. If you want to get fancy in that same application, you can embed maps in your PowerPoint and they'll be live if you're logged in. It's kind of cool. Arcgis for AutoCAD, I assume many or most of you use AutoCAD to connect to those rich data sets. There's a free plugin right there. If you're interested in BIM and getting started, how that works with BIM and GIS together, there's a blog there that takes you to some resources. And if you go to learn.arcgis.com, we have more free learning than you can probably accomplish with the remaining life that you have. There's a lot. And I'll go back to that slide, but I wanted to close with it's not the strongest. He didn't actually say this, but it's attributed to him. It's not the strongest that survived, but it's nor the most intelligent, but the most responsive to change. And that's what I think surveyors today are a lot different than surveyors 15 years ago when I came to Esri. And in a few years when I retire, I hope that, that they carry the torch and continue to adapt and change as well. And that was a lot of me talking. So let's have some questions.
There you go. Is anybody, so your ArcGIS works with CAD, but what about Carlson?
You know, Carlson actually built an application, a field application using one of our developer kits.
Okay.
But I don't know. I don't know if it does or not.
Gotcha. Yeah, I would imagine it's probably, I mean, the Carlson's definitely taken on a little bit more with surveyors using it, but I would still say it's probably maybe 80-20 or, 75-25 AutoCAD.
Call Bruce, man. I've been talking to that guy for 15 years, man. Call him and say, it's time, buddy.
It's awesome. Does anybody have specific questions? Do we want to ask Brent?
Monarch is on the cusp of being shut down. We're broke with this war.
How would you suggest presenting this to CAD techs that don't currently use GIS? I would start with ArcGIS Online and Maps for Office. Keep in mind, we're not doing drawings here. We're managing data. That's a real different concept. So when you're managing data, you're having the data draw the map, not drawing a map that creates data. You can do that, but generally we want to take the information that you collect and then create information from that. I would start with ArcGIS Online. I'd log in, I'd get a free account, and I'd start playing with it and seeing what data you can find. You can find the National Geodetic Control Network if you want. This is dangerous. Okay, I never do this. If this bombs out, I'm blaming it on the bandwidth. That's what I always do. Okay.
But you said you have fiber at the house.
I got 40 videos on here. You go to arcgis.com. Yeah, it's going to be super slow. Who knows, man? About everybody's watching the Final Four tonight, right? We got to get off the line before that thing starts.
There you go.
Yeah, so it's going to be super slow. But if you go to ArcGIS Online, arcgis.com, sign up for a free account, look for some tutorials. There's try ArcGIS Online, create maps, share maps. It's super, super easy, okay? And I will tell you, if you want to get started, this is how you get started, because ArcGIS Pro is it's for a professional GIS user. So yeah, this is gonna load uncomfortably slow. So
well, I'll throw all of the links from your slides in our follow-up emails as well, everybody. So we'll have that in
okay.
there. Then I'll get your PowerPoint. Connie wants to know how we're going to make money at this, or make money.
Well, okay. If you go back to that, if you go to this slide, there's two ways. Well, there's many ways. One is understand the end customer. I built an application one time that built pipeline. I didn't build it, my team built it. That built a pipeline alignment sheet out of a database. It saved 40 hours of drafting per sheet. Well, saved 36, took 40 hours of drafting, took it into 4 hours of data entry. And if they wanted to reroute the pipeline, It would regenerate the alignment sheets. Presented that to an engineering firm in Canada. And the guy said, the president of the company said, Brent, that's nice. I'm not interested. Even though the entire drafting department who was in the presentation was watching with white faces. The president of the company said, I sell time. Show me how to lower my rates and I'll buy something from you. This is literally what he said. So it made me realize that the efficiencies for the work I was doing wasn't up here in the design. The efficiencies were delivered to operations. So I went to these guys. I said, listen, this is what you need to do. And this is why you need to do it up here, because this makes your life down here so much better. So looking at these tiers, how do you break out of this and deliver additional services? Can you set up a project tracking site? Can you deliver information faster and in newer ways? What is being done with that information that you can enhance? And understanding that the more information that you provide, the more efficiency the entire operation becomes. That, and quite frankly, the Parcel Fabric. You know, there are 6,700 parcel mapping jurisdictions in the country. And maybe 500 are using the Parcel Fabric, maybe less. So I think that's some serious opportunity.
Perfect. What about we talked about it when, just as you were getting into the web base, so kind of the project management side of it, where you can load your CAD file into the cloud, load the drone aerial that went with it, and all that stuff where it's in this project folder setup that you can just forward on, you know, the link, almost similar to like a Dropbox or something like that. But is that under just the straight web services?
Yeah. The see if this loaded up. So this is what it looks like when you fire up Arcgis Online. If you go to the map, you would create your data and then connect it into this system for delivering as a service. You can have, there's several ways to do this. You can have your data on your server connected to Arcgis Online and published out. You can have your data on your server and directly publish out if you have a web portal. That's a little bit more technology. But you can use this platform. Now check this out.
Okay.
Okay. So this is what it looks like when you turn it on. I'm going to search for some data. What do we want to find? Let's see. We'll search Arcgis Online. Let's search survey control.
Yeah,
Maybe
there you
that's
go.
good.
Survey control. Yeah.
Okay. Okay. We're not coming up with much here. Let's search the Atlas. There we go. So these are some control stations in Hong Kong. Now we're only interested in United States. So we can filter our search to the map view. How do we do that? There's a way to do this. It's interesting because the word survey, ACS is the, you might be familiar with that, the American Community Survey.
It shows you how much the surveyors are using this.
Yeah.
You can't find a sample.
Here we go. There's no's. Okay.
There you go.
Okay. Now, we don't know exactly who loaded this one.
Okay.
Because we don't have an authentication. We don't have an authoritative button here. All right.
Okay.
Some of our data layers, see this? We have these ways to authenticate the data.
Perfect. Okay.
Okay. But if we add this one, let's see what happens here. So we go here, we can zoom in. Then we get the information on that. If you hit this guy, takes you to the NGS data sheet, I think.
Yep.
Yeah. Okay. Now, probably going to lose everybody, but I want to do this, man. I'm going to save this. Okay. This is a test control. Can delete. Now, I'm going to save this map. I want you to check this out. Okay. I'm going to share this. Okay. I can share it with the public. Okay. I don't want to share it. Maybe I have to. Okay. Well, let me go back. I'm going to go back because I'm going to paste this in your map window. And just like that, you guys all have this map. Okay. If I want to embed this map in a website, like maybe you want to have a map of all your projects, right here is the code that you would paste into your website. So if you want to have a map of all your projects, of where you're working, boom. And you can do that just internally. You don't have to do that publicly, okay? Just to point that out. Now I'm going to create an app. Okay, let's see. I don't know what the best one would be. There's all these ones you get to choose from here. They look like they're all mature, support. Simple map viewer. We'll do that. Okay, create a web app. Test control, survey demo, and delete. That's just for my own use. And it's going to take me to this little map wizard, this template wizard. I know my wife's got the basketball game on. That's what's going on. But this actually does take a little bit of time because it's resolving all those things that you futz around with trying to make a map look good. Okay, so let's see. Web map title, general, looks good. This is what it looks like. See this? So I can change the colors of that stuff, the theme, like if I want it more gray, maybe I want this ugly color here. Maybe I want the text to be that color, maybe that color, okay. So then I can go options, find location, home, extent button. Yeah, so these are map options. Do I want to be able to search? I'll leave the geocoder on there because it's kind of interesting because that will, I'm going to save. Now I'm going to launch. Now, this application is responsive, meaning no matter what device you pull this up on, it's going to recognize that device. If it's an iPad, if it's a small iPhone, big iPhone, Android, whatever, it's going to recognize, or your desktop, it's going to recognize that. All right, so there's our app. We just built this, okay? Now I'm going to paste this in the window. And you guys can pull that up. Tell me if that works. Now you guys have it. You have a Non-Gis control app now that you can use, just like that.
Got it. Yeah, definitely super fluid. And
you email it to yourself and try it on your phone. Okay. So not that you would do it exactly like this, But that's the power of services. Somebody published this service, we consumed it and did all this stuff just like that. And again, if we had one of our technical people do this, you know, I generally tell people that demoing software, it's like playing an instrument. We can all pick up a guitar and hit some notes, but that doesn't make it music, right? And this is just kind of hitting notes. A skilled person doing this would have been able to explain it better and show more things. But, you know, we did this little configuration up here, these hideous colors and
Yeah,
that sort of thing.
cool. That was good. Thank you. Thank you for going through that. Anybody else have more questions?
Oh, hey, I got one here. Monument control sheets or centerline ties. Is it possible to have live data linked between AutoCAD and the web servers? Is it dependent on manual system update? You know, that's a really good question. There's some connection between AutoCAD blocks and ArcGIS. I don't know what that is. I don't know if that block structure can keep the geodatabase up to date. A lot of places run overnight, they run an ETL, extract, transform, and load. So instead of sometimes to build, you know, we can talk eloquently about how services are really cool. A lot of times, too many different pieces of technology just makes it too expensive and cumbersome to connect everything the way you'd like. But if having that data refreshed daily works, you build this automatic extract, transform, and load system. Pulls the data, transforms it, and loads it. So when you're using it, you're getting yesterday's data. Some places actually do that hourly, which is fine too. But there are a lot of ways to work with disparate technologies that make it kind of easy. How easy to bring ArcGIS online data that's been collected in a project coordinate system? Like if you mean like 5,000, 10,000 project coordinate system versus like, you know, I don't know, a HARN or you know, your own low distortion projection or something. I don't think it's very hard. You may have to georeference a couple of the points to pull it in, to do a drag and drop, pull it in. Or you can use ArcGIS Pro to do that and then bring it in. State plane's easy, yeah. Yeah, we have several hundred coordinate systems in there. Hey, Connie, you can do this presentation for me next time. How's that?
I was thinking the same. That was awesome.
Yeah, I
We're gonna have
appreciate
Connie
having
on
somebody
next
on the
week.
call.
I
Knows
have a
what's
little bit
going
of a
on.
GIS background, but yeah,
Oh,
thanks.
good. Well, I hope I didn't say anything out of turn. I hope you're
No,
keeping me honest here.
remember Arcgis? That's my GIS era.
You know, I started in Arcgis.
I used to teach Arcgis. I went through the ESRI little school for Arcgis, and I was the instructor for a while.
You know,
A couple of dealerships, but I haven't done much in about last 10 years, so I'm playing catch up right now.
well, it's taken us 15 or 20 years to get back to where Arcgis was.
I still miss it.
Yeah, the whole GIS thing has changed. AutoCAD has changed, but not structurally. It hasn't changed a lot. It's all still DWG based, but to get to where we are now took quite a bit. Yeah, that's cool.
Awesome. Anybody else have any more questions before we let Brent go? Who are you going to root for?
You know, I don't know. I got to say, that Gonzaga game with UCLA is one that's going to go down in memory, you know?
No kidding. I did actually get to watch that one. That was a really good one.
Okay, now I want to give you guys, here's my email, okay?
Perfect.
If there's something you think of, you need connected to somebody, you got a question about something, you know, don't hesitate to shoot me an email, please. And if this was valuable, if there's another GIS topic you would like, this is really kind of an overview. I mean, if you want to dig into something like BIM or, you know, managing field applications, I can point you to a lot of recorded webinars, and maybe we get somebody else to do one of these mentoring Mondays also.
Okay, cool.
If there's enough interest.
I'll do a follow-up email everybody with I'll put you with Brent's email and then your links that you had before. So yeah, Jen, I'm interested in field apps. And I think, yeah, that's probably maybe the next one that we try to find somebody to talk about that and how we can get things set up. That would be cool.
Yeah, well, I'll tell you, if you've got, because you got the major investment, right? Just put that on the Schutzproof fund. You guys have the major investment. You've got that wicked expensive GPS stuff, right? I mean, you got the good stuff. If it can broadcast Bluetooth, you can use all those field apps.
Very cool. Perfect. Well, we'll let you go. I appreciate it. We use Survey 123 in the field, despite the name. It's not just for land surveyors. There you go.
No, that's right. Yeah, I'll tell you about real quickly on Survey 123. It's a responsive survey, so it's like asking questions. So, like Collector, you collect data from a feature service: the trees, the pins, whatever the feature you're collecting. Survey 123, you set it up so, like, if it's a tree, is it an ash, a maple, or a redwood? Redwood. Is it a sequoia? Is it coast redwood? Right. So you can set up those responsive questions. So after you answer one, it gives you a second tier of questions, and then and you set that up in Excel, and then you publish that out, and it sets up Survey 123. So again, you don't have to be a computer scientist to get this stuff to work.
Yeah, we use it. I require it for my guys on the boundary. So whenever they're doing the monumentation, they as they shoot the point, the Trimble and data collector and Survey 123 talk together, and they collect the monument information and they get me pictures. And then as it gets brought in via, I forget the name of it, the one that produces maps, I actually get monument recovery sheets made up that look very similar to a lot of the county GPS station monument sheets. But that way I have a lot of info at my fingertips to analyze the boundaries. Plus, my field guys don't forget to collect critical data for each monument. And at the end, they take the picture with Survey 123. So if they found nothing
Right.
and the county surveyor is asking me, I can tell them, look, we took a picture. We really didn't find anything there, and we dug to the bedrock. So it can be pretty useful.
Yeah, you can actually make a Survey 123 form for your website for somebody requesting a survey. Hey, put in the information that you have, what's your location, and some basic stuff. So Jocelyn, if you want to do a user story, if you're using Survey 123, doing inverts and that sort of stuff, we're happy to help you, get the word out on what you're doing.
Yeah, I was thinking the same between Jocelyn and Connie.
Yeah, it sounds like we're doing the same thing Connie is, but we love it because it's real time, so we don't have to necessarily wait for the surveyors to get back if we're trying to, you don't get the position information to the level of accuracy we need for boundary work, of course, but we can help them out with, hey, I didn't find the northeast corner, where do I go next? And we can see what they found already and decide what direction they need to move, where they need to look next, type of thing.
Yeah, there's a feature in Collector where you put in a coordinate and it takes you to that point. So you guys probably have that in most of your equipment too, but
Yeah, and what you can also do once the point is shot, then you can make it display the actual shot field and replace the pre-calc field so that you can see where the monument was shot. And then later on, as you run it through a StarNet and get a third set of coordinates when they've been adjusted and upload that into the database, then you can also have your final monument position showing.
Yeah, you mentioned StarNet. The adjustment engine we use is DynaAdjust. It's an open source. Feel free to search it on GitHub. You can download it for free and use it. But that's the one we use. It's pretty good.
Is that the one that's in the Parcel Fabric?
Yeah.
Thank you.
Awesome.
Yep.